Okay, students, so welcome and today we'll solve one of the paper of Engineering Physics 2, March 23-24. Now, all of you can see on your screen there is a question. Find the fractional increase in the mass of a particle moving at a velocity which is 0.2 c. So, we need to find the fractional increase in the mass. For this, we know the formula as m upon m0 is equals to 1 minus v square by c square. Now, when we substitute this value 0.2 c, the fractional increase in the mass m upon m0 is 1.02. In the same question, we need to find the velocity if mass is given 1.5 times its rest mass. So we have given m upon m0 is 1.5. When we substitute in the same formula, we'll get v as 0.746 c. Now let's move towards the next question, where we have given a scalar function 3x square y minus y cube z square. We need to find the gradient of this function at a point -1, -2, 1. Now we know the gradient formula as gradient of a function, a scalar function, is I cap del phi upon del x plus j cap del phi upon del y plus k cap del phi upon del z. Now when we substitute this value and when we differentiate this at the end, after substituting the value of x, y, z, so we'll take x as -1, y as -2, z as -1. When we substitute this, we'll get the gradient of phi is equals to 12i minus 9j plus 16k. Let's move toward the next question, is where we need to calculate the resolving power. We have given grating which is of length 7 centimeter and total number of lines on a grating is 8000 per centimeter. So from this given data, we know the formula for resolving power is n into n. Resolving power is n into n. Now we know total number of lines since 8000 lines per centimeter multiplied by the width 7. So total number of lines will be 56,000. And for finding n, that is order, we'll use this formula which is known as the grating formula. We call it as grating formula. And using this grating formula, we can find the maximum order which is possible. So for maximum order, we'll take sine theta maximum which is 1. When we substitute, we'll get the maximum order is 2. So the resolving power is n multiplied by n, which is 1,12,000. Now move towards the next question, which is based on fiber optics. We have given a step index fiber, core diameter is given, refractive index of core is 1.56 and refractive index of cladding is 1.5186. We need to find the maximum mode it will support, whether it is single mode or multi-mode. So we know the formula for finding V number or normalized frequency is pi d divided by lambda into n into a. And after solving this, we got the value of B as 32, which is more than 2.405. So we can conclude here that this fiber supports multi-mode. This fiber will be multi-mode optical fiber. Next, question number 4a in our question paper is given the fractional refractive index is 0.005. Refractive index of core is given 1.5. So by using this formula of relative refractive index, we can find refractive index of cladding 1.4925. And from this we can also find critical angle as 88.18 degree and acceptance angle is 2.717 degree. Numerical aperture we can find as 0.04742. Now moving towards the next question, question number 5a, where we have given a light of wavelength 600 nanometer falls on a single slit which is of width 0.2. So we need to find the width of the central maxima and also the linear width. We know this grating formula d sine theta equals to n lambda. So I can write sine theta is for order 1, where n stand for various minimum order. For order 1, for n1, We can rewrite this sine theta is lambda upon d, and from this we can find the angular separation. Total angular width will be double of theta, will be 0.344 degree. We also know the formula sine theta is x upon d, where d is 2 centimeter. And by substituting this detail, we can get the linear width as 120 micrometer. Now let's move towards the sixth and the last question, where we need to find the resolving power again. There is a grating of 3 centimeter wide having 5000 lines per centimeter. So we again know the formula for resolving power as maximum order multiplied by total number of lines. Total number of lines we can calculate and it comes out to be 15,000. Using the grating formula, so we'll use this grating formula. A plus b sine theta is equals to n lambda, and substituting the detail for maximum order sine theta will become 1. We'll get the value of n as 3.39, and from this the resolving power will be 15,000 multiplied by 3. So 15,000, 45,000 will be the resolving power. Thank you very much.